equilateral by the length of its sides. So for these two problems, you may need to use the distance formula. It's not always required. There's some other ways around it, but distance formula, just in case we need it, is going to be x minus x squared. For some reason, that doesn't want to do that. There we go. Plus y minus y squared. And then we square root that. It's just a variation of the Pythagorean theorem, a squared plus b squared equals c squared. If we have, though, on our triangle, if we have sides that are just straight vertical or horizontal, we can just fill in, like that side's going to be 3, and that side's going to be 4. So we know the lengths of those two sides. So far they're different. Then we would check this third side, and I would use Pythagorean theorem to figure that out. 3 squared plus 4 squared equals c squared, and that's going to be that c is going to equal 5 when I solve that out. So I have all three are different. That one's going to be scalene. So scalene for number 20. And then number 21. So looking at this real quick, we can use the distance formula, but here if I look, the side goes 3 over and then goes 1 down, and then this one goes 3 down, 1 over. So they're both kind of going that same 3 by 1, 3 by 1. That's going to mean these two sides are the same. And then this one's going to be different. It's longer. So that one's going to then be isosceles. So 21. You don't always have to use the distance formula. You can just kind of check the angle of those sides, and then you could see that 2 of those sides would be congruent. The third side would be different. Hopefully that helps, and let me know if there's any others.